So here's a prototype LED strip for the paramotor. It's in a ring. I've actually got, if you look here closely, they're JST connectors where the frame actually breaks apart so that I can still take my paramotor apart. This is actually the second prototype. These are WS2812 single wire addressable LEDs. I have to power it from both ends here. If you can see, this one doesn't have a data connection on it, just this one here. That way these leads over here maintain full brightness as well as these over here, because you have voltage drop going around the circle. So when we turn it on, let me turn it on over here. And then we'll reset. I'm just using an Arduino Pro Mini. You could actually use any Arduino. Doesn't really matter. We'll reset it. And actually here, I'll do that again. When you reset it, you'll turn it on for the first time. It goes red, green, blue, and white on the entire ring, just to let you know it's on. And then we have hooked up a button here that cycles through all the patterns. I push it once, got American flag, and it's actually quite visible from the air. And you can't see it, but that's really blue and white. My camera's not doing it very much justice there because it's really bright blue. And then if I cycle through, I just have a couple test patterns here. Let's see. That's a rainbow fade, all the LEDs. And then this one is a color swipe. It's just like theater lights, I guess you'd call them. And this one is just like it's a rainbow circle, and I can adjust it. I've got a little potentiometer right here that I can twist that adjusts the rate. At which and how long the bars are. See how the bars are getting longer? And you could like leave it at one setting. You can speed it up. If you slow it down, the bars get really big. And you can shorten the bars and speed it up again. And if we push a button again, that one's LEDs balancing back and forth, which you can use the potentiometer to adjust the speed, how fast they bounce back and forth. They're really slow, really fast. And then we can push the button, turn them all off again, and then just cycles through all the patterns. And then it's just Arduino code, but I'll show you that here in a minute. But right now we're going to go into the shop. I'm going to show you how I actually make these LED units. And actually this is for my paramotor, which is a FlatTop. And it happens to work out perfect that it requires 240 LEDs to light the entire ring. And 240 is a great number because it's divisible by 2, 3, 4, 5, 6, 8, 10, and 12, I think. So I can do quite a bit with it. So if you're going to do one for yourself, try to make the LEDs, the number of them that you use, divisible by as many numbers as possible. That way you get a good even split on all the sections, so you can display, you know, like parts of the flag and stuff like that, and it just comes out good. Anyways, let's go to the shop and see what we got going there. Alright, we're in the shop now. So these are the new LEDs that I bought. I don't know if you can see that, but these are silicone covered. Addressable. I cut these off. Then this is a 5 meter length of the LEDs. So that's basically 300 LEDs. And on my cage ring, to light up all of the LEDs requires almost 5 amps at full brightness. So you actually can't get away with that. And then I actually sticky mount it to this outdoor 3M mounting tape. It's the light gray, and that gives a little bit of thickness around the rim, so it conforms to the roundness of the ring. And then also, this is super sticky. Once you get it on there, you are not getting it off, but you have to be sure to put it on there when it's like 70 degrees or hotter. And I recommend bringing your motor inside and then using a heat gun to actually warm up the strip and the lights and your rim before you stick them on. And so what I'm going to do is I'm going to prep these and film it and show you what you do to make a strip. So let's do that. I got to go get the tripod. So I'm going to show you how to do one of the strips. So on my paramotor, I need two 24 LED strips, and I have it marked off right here. So if I go from here to there, that's 24 LEDs. And what I do is cut it at the 24 mark, and then I don't keep this in, so I cut it off too. And that goes in the scrap bin. And then I don't know if you can see this, but there's an arrow next to each LED that points in the direction of data flow. You got to make sure to keep that in the same direction on the hoop. So then what we do is I'm going to cut two of them. I'm just going to cut an extra one off, one there. So I always leave myself a little extra there to solder to. And that's why I cut the lead a little longer on that side, so I can do the same thing over here. Cut that off. And then these two will get stuck down to this tape. And again, it's the 3M Outdoor Extreme. And then what you want to do is I pinch it down like that, roll it out to here, and tape it down. And I take my heat gun, warm it up a little bit. You need to get it above the 70 degrees. You can see it'll start curling a little bit, and that lets you know that it's warm. And then what you do here, you just start peeling this off. You stick it down like so. And keep this one lined up against the edge here. Careful not to touch the other side there. See, look at that. This is how crappy the glue is. It's still sticky on the wrapper here. And if you don't do that, if you just try to stick these directly to your motor, I guarantee you they'll fall off, which you don't want. Because you could have a motor out, your prop could explode, all sorts of fun stuff. This one you want to get it close so that you could just fit a razor blade between the two. And no more. And then you want to push it down. What I do is warm it up again a little bit. You want this to be adhered really well because you don't want this coming off, period, at all. And then you take your knife like so. What I do, start down this side here and cut along this edge. And then cut across. Put this tape back over here. This should come right off. Just that little piece. And now, while it's still on there, I'm going to split this in half. And generally your knife will follow the groove or the crack. Boom. And once you do that, you want to cut it across the top, like so. And then, voila. You've got two lights with the sticky pack. And that extra thickness gives you a little cushion to go around the tube. So like if this screwdriver was the tube, when you push it on there, it can actually conform better because you've got that maybe a 1/16 of an inch of foam between there. So now that we have these, we got to make sure that both the data arrows are pointing in the same direction. And then what I do is take some of these. So what I've been doing is putting the, I don't know, I guess you'd call that the male or female side, I don't know. But putting this side down here, like that. And then the other end, the receptacle side here and here. But these don't need to be the full length, and I'll put a link in the description for these on Amazon, but they're like 6 inches long and they don't need to be that long. So what I do is I've got it measured out here. I only go 3 inches. Now when you do this, you're actually cutting off the soldered ends that they already did for you, which means you're going to have to redo it, which is not a big deal, but it's just more time consuming. What you do is that, like that, and then cut this one. I'm only doing these two just to show you. I'll finish them up off camera, but So there's that, and then, you know, these are really handy, but you can stick them like that and then go boom, and they're all stripped. And you can get these at like Fry's, or you can order them online. They're not that much and totally worth it. And then once you do that, you're gonna want to just solder the tips. If you don't do that, you're gonna be sorry and have lots of problems soldering these on. So I highly, highly recommend that you tin these tips. So what we do is we get a little bit of solder here, heat up the soldering iron, a little bit of water in there. Then we just tin them. All right. So now that we have these, what we need to do is take this stuff here. It's like that mesh tubing that expands and contracts. And then, oops, excuse me, we're going to cut about 1 inch shy about that much right there. So we'll just double it back like that. We'll measure 4 of them. And these go on top of these. Like that. All right, so I used this and I slowly, if you can see it, cut down through the silicone layer and then peeled it off. It actually takes a little bit of effort to do that. And then now what I'm going to do is solder that on. I'll show you. So I'm soldering the leads on here. So there's one soldered on there. Oops. And you gotta make sure you get the 5 volts, the ground, and the data on the right one. And then you slide this over the top. And I put it right here, just below the first LED. Make sure this is all the way up. And then there's first connector on. The last thing you want to do on all of these is the back where that tape peels. You want to cut it like right across there, but not very deep, just deep enough so that when you peel the red stuff off, it comes off. Like that. But this is the finished product here. And this will be put on the ring later. I'll show you because we'll do that on my motor because So I'm gonna tear off the other ones. The other ones are the original ones that I put on were some cheapos that I got from overstock.com, and they didn't have silicone coating for weatherproofing. And a lot of times I drive with my paramotor on the back, and it's raining, and it gets wet, and so my LEDs are probably going to start rusting away pretty soon if I don't switch them out. So some of the challenges that I faced while developing the super lights for my paramotor was the LEDs, wherever you plug them in at the start, that becomes LED 0. It was kind of inconvenient to make the center, the first lead, like the center of the paramotor. To do that, I would have had to have connectors like in weird spots, and I didn't want that. So one of the design goals of it was to actually have every connector at a disconnection spot where the frame actually comes apart. So that meant I had to deal with pixel 0 not being exactly where I wanted it, and what I ended up doing was utilizing top dead center as pixel 0. And then I had to write the algorithm to basically map a virtual pixel to a real pixel on the ring. And the code does it for both clockwise and counterclockwise rotation around the ring. That's how I can like do the fancy lights that dance starting from the top center and goes down around to the bottom center. So this is the setup here, and I'm using, this is actually from Micro Center. It's a knockoff of an Arduino Pro Mini. It has the same pinouts basically, but the board is completely different. But it does have the programming header there, so you have to use one of these boards here. It's the FTDI breakout board that plugs into the end here, and then you can program the board. But you can basically use anything. I also have the Adafruit boards. This one is the Metro Mini, which is basically very similar. It has the USB connector already built onto it, so you don't need that. And then the final product will have an Adafruit Itsy Bitsy, which is another kind of Arduino compatible board. But you can write the code once and you can upload them to any of these boards. They don't have hardly any memory, and they've only got a little bit of flash, so most of the pattern routines are actually developed and displayed in code and not like using a bitmap pattern. Although I do have the code written to display bitmaps, so you could actually create a pattern and then give it to the display routine as an array, and it'll spit it out for you. But this is the cycle button that cycles through all the different patterns that you have programmed. And then this is just a potentiometer that when you twist it just gives you a variable number between 0 and 255, which then I use to adjust brightness or color or whatever. Depends on the pattern. And there's my power supply that I'm using to power up the leads. Unfortunately, the leads eat up a lot of power, and they're 5 volt, and that's going to be an issue for some people because there are no batteries that are 5 volt, so you end up having to use a regulator of some sort, and then the regulator has a power rating on it, and therefore you can only get so much. So the original project started with a regular USB charger battery for your phone. It was supposed to be a 5,000 milliamp battery, and the ports on the outside were marked 2.4 amps and 1 amp. Well, I quickly discovered after load testing it that the most that thing could generate, period, even with both the ports combined, was 1.4 amps. So nowhere even close. And I tried a couple other ones too, and they're all basically the same. To get the full, 2.4 plus the 1, so 3.4 amps out of that battery, it would get really hot fast. And I guess they just like to lie. And so if you're using one of those batteries, what you have to do is adjust the brightness of the LEDs. And then what I do is when I turn it on here, my power supply, it tells me how much current is being drawn for whatever pattern. And then I can adjust the brightness of each LED to pull it down to what the battery is capable of generating. Now my new setup, I have ordered from Hobby King a couple 2S 4000 milliamp batteries. They're 7.2 volts. And then I ordered 2 BECs, which are just basically voltage regulators for quadcopters. And they're supposed to be 10 amps a piece and adjustable to 5 volts, which is what I need. And so if I can get 5 volts at 5 amps, because this whole ring here, if you turn it on bright white and crank it all the way up, it draws 5 amps of power. So I'm hoping that with that battery and the BEC that I can actually get the full power out of this and get the full brightness. Right now the American flag is scaled back in brightness by like 80%, so it's only 20% of its brightness capability. And actually I can show you, because here, look, let the camera color readjust here. And then if I crank this up, so there's the American flag at full brightness. And at full brightness, we're sucking 2.6 amps of power at 5 volts. Which is about half of what these lights are capable of drawing. Now if I scale it back to what my charger battery is capable of, which is only 1.4 amps, which is right there, and they're that bright, which at night you can actually still see it really well, but I want the full brightness if I can get it out of it. So I get the new batteries and voltage regulators tomorrow. So tomorrow I'll hook up and get together a new ring with the new setup, and hopefully I can get the full brightness out of it, and then we'll hook it up, put it on the Paramotor, and show you what it looks like, and I'll also show you all the different patterns that I've been working on. Right now I just have the American flag and a couple other things, but I've got some other ones that I've been working on too. So we'll catch back up tomorrow and finish this off. See ya.